This method can help improve characterization of organic matter in environmental solid matrices, such as soils and sediments. The main advantage of this technique is that it can reduce mineral interferences in soil spectra that limit interpretation of the organic matter component of soils.
The implications of this technique extend to other environmental samples dominated by minerals beyond soils, such as sediments and fossil minerals. Generally, individuals new to this method will struggle with determining an optimal subtraction factor. It is important to keep in mind that this is operationally determined by your experimental goals. Keep this in mind when exploring subtraction factor values. My laboratory has been doing subtraction work for about 10 years now, with the main objective of identifying absorbance bands associated with soil organic carbon quality. Originally, we wanted to study the role of wind erosion on the removal of different forms of soil carbon from agricultural soils. Visual demonstration of this method is helpful because the labor-intensive oxidation steps and adjustment of the subtraction factor require some practice by doing, which can be informed by watching how others perform these procedures.
First, sieve soil to less than 2 millimeters using a stainless steel mesh. Following this, adjust the pH of 6% sodium hypochlorite to 9.5 by adding 1 molar hydrochloric acid dropwise to the solution while mixing and measuring with a pH meter. Add 25 milliliters of pH 9.5 sodium hypochlorite to 4 grams of the sieved soil.